Meet the PigeonBot II, a marvel in AI-powered robotics. Imagine a world where machines don't just fly, they feel the wind. Where wings are living, reflexive systems that move like real feathers in a storm. Meet PigeonBot II, the AI-powered robot that's changing how we think about flight. This isn't your typical drone. It doesn't rely on bulky rudders or rigid wings to steer. Instead, it's designed to learn from nature's most underrated pilots, pigeons. Yes, pigeons. The same birds you see on sidewalks and telephone wires. Turns out, they've been perfecting aerodynamics for millions of years. Researchers at Stanford University, led by Eric Chang, wanted to uncover how birds maintain stable flight without vertical tails or rudders. Birds don't have flight computers, yet they glide through turbulent air, make sharp turns, and land gracefully. The secret? Constant micro-adjustments. When air hits their feathers, it triggers reflexes that tweak wing angles and tail spreads in real time. Think of it as an organic autopilot, powered by nerves and instincts instead of code. That's what PigeonBot II set out to copy. The team built a biomimetic skeleton, meaning the robot structure imitates a bird's anatomy. They didn't stop at plastic and metal joints. They used 52 real pigeon feathers on the wings and tail. These feathers are key to the robot's control system. As wind flows through them, sensors detect subtle pressure changes. Those signals feed into an AI-driven reflex algorithm that automatically adjusts wing shape and tail angle to keep the bot stable. The result? A flying machine that can tilt, expand, or curl its wings, even wag its tail, all without a rudder. It's like giving a robot a nervous system. Here's where it gets wild. Airplanes maintain stability using fixed parts, a horizontal tail for pitch and a vertical tail for yaw. But birds rely on dynamic geometry, constantly reshaping their wings and tails based on airflow. This flexibility lets birds adapt instantly to turbulence, gusts, or sudden turns without losing balance. Aircraft engineers have chased this agility for decades. PigeonBot's morphing design might be the closest we've come to bridging that gap. In early wind tunnel experiments, the first prototype, Tailbot, showed promise. It had fixed foam board wings and an adjustable tail with real feathers. Tailbot could automatically adjust its tail to counter Dutch roll instability when a plane rocks side to side while yawing. But outdoor testing was rough. Turbulence threw it off balance, leading to crash landings. Instead of giving up, the team evolved the design. Enter PigeonBot II with morphing wings, wrist-mounted propellers, and advanced reflex-based AI control. It wasn't just prettier. It was smarter, stronger, and more adaptive. So, how does it actually stay stable? Picture flying through a gust of wind. As air pressure changes, PigeonBot's sensors detect turbulence. The AI instantly triggers tiny feather adjustments, tightening one wing, loosening the other, or tilting the tail. These reflexes happen faster than any human pilot could react. The robot feels the wind and corrects itself before instability even starts. In testing, this system successfully stabilized flight through takeoff, cruising, and landing, all rudderless. That's huge. Removing the rudder doesn't just make the robot lighter, it also makes it stealthier. Without a vertical tail, radar detection becomes harder. That's why defense and surveillance teams are paying attention. A future aircraft that flies like a bird could be almost invisible to radar, efficient, and capable of flying in complex terrains, urban areas, forests, even disaster zones, without GPS. Eric Chang said it best: "Our research unlocks the secrets of bird flight and opens the door to more efficient and stealthy aircraft." That's not sci-fi talk, that's science catching up to nature. The PigeonBot team didn't just prove it could fly. They wanted it to learn from every flight. So, they gave it a reflexive control system, an AI model trained to mimic how real pigeons respond to aerodynamic changes. Each test flight refines its understanding of turbulence, making it smarter over time. It's the robotic equivalent of a bird building muscle memory. And that's what makes this project so groundbreaking. It's not just about mechanics, but about behavior. If you zoom out, there's a beautiful symmetry here. The first airplanes were inspired by birds. The Wright brothers studied pigeons and eagles. Over a century later, Engineers are looping back, studying birds again, not for inspiration, but for replication. PigeonBot II is a full-circle moment for aviation, a fusion of biology, robotics, and AI that redefines what flight can be. Watching it in motion, you can't help but feel awe. The wings flex, the tail fans out, and the body subtly adjusts, not stiff and mechanical, but organic and alive. And it's not just a lab curiosity. This technology could shape future search and rescue drones, environmental monitoring robots, or eco-friendly aircraft. Imagine a fleet of AI birds helping survey wildfires, monitor air pollution, or map out disaster zones, moving with the same elegance as the real thing. It's one of those ideas that sounds poetic until you realize it's already happening. So what makes PigeonBot II special isn't just its flight, it's what it represents. It's a reminder that the smartest technology often comes from paying closer attention to what's already around us. Birds mastered balance and control long before humans ever left the ground. Now, AI and robotics are simply taking notes. Maybe the future of flight isn't about outsmarting nature, but collaborating with it. A feather here, a reflex there, and suddenly, we're witnessing the next chapter of aviation unfold, one graceful wing beat at a time. This is PigeonBot, the robot that learned to fly like a bird and maybe, just maybe, to think like one too. If you enjoyed this deep dive into AI-powered robotics, hit subscribe and stay tuned for more stories from the edge of innovation. See you at the next one.